We are back with the next video, part 13. Now in this video what we are going to do is they give us an equation x minus a the whole squared plus y minus b the whole squared equal to c squared, and they ask us to find this expression. They say that it is independent of, they give us a question that independent of a and b means the answer that you get does not have a and b. That's what they are trying to tell. So this expression, when you try to find out, you'll get an answer, and that answer will not have a and b. That's the meaning that they tell us. As you see the videos, you please also you will share the videos. You will also subscribe to the channel, and you should ask your friends also to do that. And you can also offer your valuable comments as to what improvement has to be done. So that's about it. And then let's come back to this. They tell us to find out this expression which is independent of a and b. So let's see now how we can go about doing it. For that, obviously we'll have to first find dy by dx. We'll have to find d squared y by dx squared, and then put it into this expression, see how it is. Now for that, in this, I hope we have learned conic section in the 11th standard. So from there it's very clear to us that this particular expression, it's the equation for a circle. So it's a circle that it's representing, and then we have to find this expression. It has lots of significance when we go for JEE. All this does have a lot of significance, but right now let's find out. Let's try to make ourselves clear as to what is this expression. So let's see now how to find this expression. Let's start with what is given to us. Let's consider x minus a the whole squared plus y minus b the whole squared equal to c squared. Since we want dy by dx, let's take the derivative. Again, this is an implicit function, so let's take the derivative. Derivative of this is 2 times x minus a. It's with respect to x. We are taking derivative with respect to x. Here it is 2 times y minus b, derivative with respect to x. So we have to write dy by dx. C is a constant, so derivative is 0. Since we require dy by dx, let's arrange the terms. 2 times y minus b dy by dx. We try to take this term on the other side, minus 2 times x minus a. So you can have the 2 cut, and your dy by dx probably is, you could have this sign taken inside, so that it will become minus x, minus of minus a, so plus a. So a minus x by y minus b. Whatever is useful to us, we will try to use this. Dy by dx is this. We require d squared y by dx squared also. So we cannot stop here. We'll have to find out d squared y by dx squared. Now finding d squared y by dx squared is your own convenience. Either that you take this expression and use this as a quotient and then find out the dy by dx, or sometimes it's a bit more convenient if you can stick over here and get the second derivative. It's slightly more convenient. I'll do that. I'll stick to this equation, and from there I'll find the derivative. For my convenience, let's call it as equation 1, and from equation 1 let's find the second derivative. So from 1, just for your reference, that from 1 we are differentiating once again. So it's a product over here, y minus b as it is. Derivative of dy by dx is d squared y by dx squared, because we are taking the derivative with respect to x. As I told you, it's a product. So next it is dy by dx, derivative of y minus b. Derivative of y minus b, we all know. Derivative of y is dy by dx, b is a constant, so no derivative. So as a result, the derivative of y minus b happens to be dy by dx. On the other side, we have a minus x actually. And for a minus x, the derivative, a is a constant, so no derivative. Minus x, derivative is with respect to x, so it will be minus 1. Please analyze it. Derivative of a minus x, derivative of a is 0, and derivative of x is 1. So that's how we are getting it as minus 1. Now let's try to, our idea is to know d squared y by dx squared. So this is now y minus b into d squared y by dx squared plus dy by dx the whole squared equal to minus 1. Let's have this on the other side, and let's see how that goes. Yeah, it is y minus b times d squared y by dx squared. This can go on the other side, minus dy by dx the whole squared. Goes on the other side, becomes minus. You could, keep this, always we can see this 1 plus over here. So we can have that thing. You can take the minus 1 out. 1 plus dy by dx the whole square. You've taken the minus 1 out. and this minus 1 can be carried on the other side. So it can become minus y minus b d squared y by dx squared equal to 1 plus dy by dx the whole squared. Either that's obviously b minus y. You can have it as b minus y, or you can keep it as it is. It's the same. So this expression, we'll just call it as equation 2, and this we can use for our further calculations. We have to find this out. So it is clear to us that d squared y by dx squared, no? Probably this can be your equation 2. D squared y by dx squared, if you could take that minus y minus b on the other side, it is 1 plus dy by dx the whole square. This is the numerator. This is multiplication, so it goes on the other side, it becomes division and goes to the denominator. Minus y minus b, you can call it as b minus y actually. So this is your d squared y by dx squared. Since we have to show this, let's get back to this expression. How do we get back? By consider 1 plus dy by dx whole squared raised to 3 by 2 by d squared y by dx squared. Let the numerator, let it be as it is, because it's sufficiently complicated. So let it be as it is. Denominator, we know d squared y by dx squared. So let's substitute 1 plus dy by dx the whole squared by b minus y, or y minus b. As per your convenience, you can write. Now, we can see that these both bases are exactly the same. Here the power is 3 by 2, and here the power is 1. We all know the property, the law of exponent, that a raised to m by a raised to n is always a raised to m minus n. So we can use that property. So also this expression is divided by this. Division by a fraction is multiplication by the reciprocal. As a result, this will be divided by this. B minus y goes to the numerator. So like that, we will get over here b minus y in the numerator, and this is 3 by 2 minus 1, because you use this law, 3 by 2 minus 1. 3 by 2 minus 1, 3 by 2 actually is 1.5. So by common sense, 1.5 minus 1 is half. Otherwise you use your fraction logic. So this will become 1 plus dy by dx whole squared raised to half. So that's what comes here. So you're getting this expression as b minus y into 1 plus dy by dx the whole squared raised to half. Now this b minus y, let's get this substituted. 1 plus, what is dy by dx for us? It's this. So let's get that substituted. A minus x the whole squared by y minus b the whole squared. So we have come up till this expression, the thing that they have asked us to consider. We have reached till this, we have to simplify it. And after simplification, we have to show that it is independent of a and b. A and b is not there. We have to show it. So let's further proceed and see how we can do it. Yeah. So what does it come to? We have come to b minus y outside the bracket. Inside the bracket, it is 1 plus a minus x the whole squared by y minus b the whole squared. Let's equalize the denominator here. Multiply this by y minus b the whole squared. This also by y minus b the whole squared. So you will get, equalize the denominators. So it will come to y minus b the whole squared plus a minus x the whole squared y minus b the whole squared, and this is raised to half also. This is raised to half. So this becomes now b minus y, and this is like this expression, we know it is c squared for us. Why? Because we had a the earlier given expression, x minus a the whole squared plus y minus b the whole squared equal to c squared. So that will allow us to put this. Now calling y minus b the whole squared is as good as calling b minus y the whole squared, no? Because it's the same. When you square it, it will be the same. So therefore this is as good as saying c by b minus y whole squared, no? Both are squares, whole squared, and 1 by 2 is outside. So that can cancel each other. You're left with b minus y into c by b minus y. B minus y is cut. You're left with a c. So that's independent of a and b. There's no a and b there. The question is that expression, when you solve it, you should get an answer which does not have a and b. And that's exactly what has happened. You have got the answer as c, which does not have a and b. So that you have to conclude that it is independent of a and b. So you can write is independent of a and b. So that's how it is. Pretty lengthy, but then this is how it is. You don't go wrong. It's quite simple. So that's it. With the next problem, we come in the next video. Thank you.